Welcome to Somali Nexus, the podcast where we reconnect the threads of Somali heritage, knowledge, and innovation. And today, we're diving into a little-known but powerful story, the hidden history of Somali mathematics. When we think of mathematics, we often imagine formulas, theorems, and European inventors. But what if I told you that centuries ago, Somali scholars were using math in astonishingly practical and intellectual ways, long before colonial narratives took center stage? From the 9th to the 15th century, Somali port cities like Zeila and Mogadishu weren't just trade hubs. They were vibrant centers of Islamic scholarship. Somali intellectuals studied astronomy to navigate the stars, used geometry to construct mosques with precision, and relied on arithmetic for religious obligations, like calculating zakat and inheritance shares. Scholars like Yusuf alKonin, known locally as al-Barkhadla, made linguistic and cultural innovations tied to abstract thinking. Others, like Said of Mogadishu, traveled across the Islamic world, mastering theology, law, and the mathematics embedded within them. Their intellectual reach extended to Mecca, Medina, even China. Mathematics in medieval Somalia wasn't locked in ivory towers. It was alive in the marketplace, practiced in coastal navigation, embedded in architecture, and reflected in the rhythmic patterns of religious rituals. Somali merchants calculated weights, currency exchanges, and taxes with sharp precision. Sailors mastered celestial navigation using tools like the Kamal, while Sufi scholars explored number symbolism and sacred geometry. And though Somalia may not have produced famous treatises, its scholars were deeply engaged in a global conversation. From Cairo's Ahar University to the trading ports of Gujarat and Aden. They didn't just receive knowledge, they adapted it, applied it, and passed it down orally for generations. So today, we reclaim this legacy. The story of Somali mathematics isn't just about numbers. It's about identity, resilience, and a rich intellectual tradition that deserves to be remembered. Stay with us. This is Somali Nexus, and you're about to hear the story they never taught you in school. Welcome to the deep dive. Today, we're setting sail, metaphorically speaking, for medieval Somalia. It's a region we often think about mainly for its coastal trade, right? Bustling ports. But our sources, they paint a much richer picture. A really vibrant, sophisticated intellectual center. So, our mission in this deep dive is to uncover how mathematics wasn't just some abstract thing for scholars. It was actually deeply woven into, well, the whole fabric of life there. We're talking religious practices, complex sea navigation, even planning, grand buildings, and of course, commerce. Get ready for some, I think, genuinely surprising facts and maybe a fresh look at intellectual history.
Yeah, what's really compelling here is understanding just how integrated this region was. We're talking roughly 9th to the 15th centuries, deeply connected into the wider Islamic intellectual network. You know, cities like Zeila and Mogadishu, they weren't just trading posts, they were dynamic learning hubs and mathematical knowledge. Well, maybe they didn't call it mathematics like we do, but those skills were absolutely essential across so many different fields. We're going to explore how they actually applied these skills. And yeah, I think the ingenuity might surprise you.
Okay, so let's set the scene a bit more. How integrated was Somalia? I mean, how did it connect into those broader Islamic scholarly networks during the Middle Ages? What did that look like on the ground?
Well, you know, right through that period, 9th to 15th centuries, places like Zeila, Mogadishu, they were buzzing. Commerce, yes, but also religion learning, they pulsed with it. And Somali scholars, they weren't operating in a vacuum, not at all. They were deeply involved in fields that just depended on mathematical know-how. Think astronomy, sophisticated navigation techniques, architecture, the complex details of Islamic law. They were absolutely part of this huge intellectual conversation happening across the Islamic world. Ideas flowed.
Right. And what really brings us alive for me anyway are the people, the individuals. Can you introduce us to some of these figures who really embody that intellectual spirit? Maybe start with one of the earliest, Ysef bin Ahmed alKonin, also known as al-Barkhadle.
Yes, Ysef bin Ahmed alKonin. He's a great starting point, 10th century from Zeila, and Zeila itself was a key hub for Islamic learning back then. His big thing, his really remarkable innovation, was linguistic. He's credited with adapting the Arabic script so it could be used for the Somali language, and crucially, he introduced a system for writing vowels in Somali. Now, think about the kind of thinking that requires adapting a script, figuring out vowel notations, like a structural problem. Almost mathematical in its precision. You need systematic, abstract thought.
Yeah, I can see that it's not just about letters.
Exactly. It speaks volumes about the intellectual depth there. And his legacy goes further. Traditions link him to spreading Islam in the Maldives, East Africa. Some even say he influenced the Walashmi dynasty.
Okay, so linguistic innovation as a kind of applied systematic thinking. That's fascinating. Let's jump forward a bit, maybe to the 14th century. Tell us about Said of Mogadishu. What does his story tell us about how far Somali scholars could travel and how respected they were?
Said of Mogadishu, born 1301, another fantastic example of that mobility and reach. He spent, get this, nearly 30 years studying in Mecca and Medina, right at the heart of Islamic scholarship.
3 decades.
Yeah, and then he traveled widely. India, possibly even China. His expertise wasn't just theology, it covered law, regional politics. Now, imagine trying to operate at that level without solid mathematical skills. Just for the Islamic scholarship part, calculating complex inheritance shares, figuring out prayer times accurately based on the sun converting between calendars.
Right. That all needs math.
Absolutely. And there are accounts of him meeting the famous traveler, Iben Batuta. Said apparently gave Iben Batuta valuable information about the Far East. That just highlights the kind of international reputation these Somali scholars had.
That's incredible reach. And our sources also mention scholarly families. The Al-Zailai family. What was their contribution?
The Al-Zailai family from Zeila. Yes, they became quite prominent, especially in places like Egypt and Syria around the 14th century. One key figure was Uthman bin Ali al-Zailai. He was renowned for his work in Hanafi jurisprudence.
A major school of Islamic law, right?
Exactly. And Hanafi law involves some really intricate calculations. Think inheritance, property, complex contracts. His big commentary, the Tabayin al-Haqa'iq, still studied. And then his student Abdullah al-Zailai. He was involved in diplomacy, representing Somali sultanates at the Mamluk court in Cairo.
So they were operating at the highest levels.
They really were studying and teaching in top institutions like Ahar University in Cairo. In fact, Somali and other Horn of Africa students had their own residence hall there, the Hassan Aljabarti.
Wow.
And you can bet their curriculum there included essentials like astronomy and arithmetic. It had to.
Okay, so it's really clear math wasn't just for a tiny elite. The sources strongly suggest it was deeply practical. So what did this mean for, everyday life in medieval Somalia?
That's the key point, really, if you connect the dots. Mathematics wasn't primarily this abstract thing. It was tied directly to practical, everyday needs. Religious education, for example, was a major way this knowledge spread in the Quranic schools. The madrasas kids weren't just memorizing. They learned basic arithmetic. Why? To fulfill religious duties, calculating the zakat, the charity owed, figuring out inheritance shares, which often involves choosing tricky fractions, establishing dates correctly, using the Islamic lunar calendar. That's mathematical too. And then there's geometry and astronomy, indispensable for things like aligning mosques towards Mecca, the Qibla.
That has to be precise.
Exactly, and calculating prayer times, which change constantly depending on the sun's position. That's applied astronomy, day in, day out.
Okay, and Somalia's coast, obviously central to the Indian Ocean trade. How did math factor into navigation? These long, dangerous sea voyages?
Oh, hugely. Maritime navigation. Math wasn't just helpful. It was critical for survival and profit. Sailing those vast distances demanded a really practical, deep understanding of astronomy. Not just recognizing stars, but using them for direction. Precision was key. Plus understanding the monsoon winds. Their cycles are predictable, almost like a mathematical pattern. You had to know.
Did they have instruments?
They did. Tools like the kamal. A simple but really clever device for measuring latitude. But what's also fascinating is how they combine that with oral star charts passed down through generations and reading environmental cues, the waves, the birds.
A mix of tech and deep traditional knowledge.
Precisely. And this combination let them travel safely across enormous distances, southern Arabia, India, maybe even China. As we mentioned, it just underscores how sophisticated their applied astronomical knowledge really was.
That is pretty amazing. What about architecture? You mentioned grand buildings like the Fakhar ad-Din Mosque in Mogadishu. How did they manage feats like that without, modern engineering degrees?
Architecture, absolutely. Another area where you see applied math shining through. Building these mosques, civic structures, it wasn't haphazard. It required careful geometric planning, structural understanding. That Fakhar ad-Din Mosque, 13th century. Its fantastic example, built with coral stone, intricate designs.
The symmetry, I imagine?
Perfect symmetry. It shows a real grasp of engineering principles, geometry. But it wasn't just mosques. Think about the Ajuran Sultanate, 13th to 17th century. They developed this incredible hydraulic system, wells, canals, managing water resources that needs serious engineering skill. Sure, but also knowledge of measurement, geometry, even understanding flow rates and environmental factors. It's complex, applied math.
And then, of course, trade. You can't have that level of commerce without numbers.
Exactly. Money makes the world go round, as they say, and math makes money go round.
Ah, right.
Commerce, absolutely, drove the practical use of math. Somali merchants were all over the Red Sea, Persian Gulf, Indian Ocean. Their success depended entirely on accurate bookkeeping, converting between different currencies.
Which must have been complex.
Very, and understanding all the different systems of weights and measures used in different ports. By the 13th century, you have the Hindu-Arabic numerals, including that revolutionary concept zero, becoming widespread in the Islamic world. It's highly likely they were adopted and used in Somalia too, made calculations much easier.
And they minted their own coins.
They did. The Mogadishu Sultanate minted coins, some with rulers' names on them, and archaeologists have found these coins incredibly far. Iraq, Oman, the UAE. That points to a really complex economy and just how far Somali trade reached. It needed math to function.
So, beyond the practical, the trade, the building, the praying, our sources hint at something more a cultural, maybe even spiritual dimension to mathematics. Can you unpack that a bit?
Yes, that's another fascinating layer. Math knowledge popped up in less formal ways too. Things like magic squares, grids of numbers with special properties and talismanic diagrams. These were common across Islamic societies and definitely found their way into East African traditions.
So, like mystical maths?
Sort of. While we don't have loads of specific medieval Somali texts on this, later manuscripts from nearby Harar or Lamu show a shared culture involving this kind of thing. Scholars, especially those involved in Sufism, the mystical side of Islam, likely explored numerology, the symbolic meanings of numbers in religious texts and healing practices.
Ah, Sufism. Okay.
Yes. Sufi orders like the Qadiriyya were quite influential. They often incorporated numerical symbolism, like the values assigned to Arabic letters, or used geometric shapes in devotional practices. So, you have these mystical elements existing right alongside the very practical math we've been talking about. It formed this kind of holistic tradition where math had spiritual meaning, educational value, and practical use.
A holistic tradition? I like that. It makes sense. So, how did all this knowledge actually get passed down? And how did Somalia stay placing plugged into that wider intellectual world?
Well, it wasn't just Mogadishu and Zeila. Other towns were important learning centers too. Places like Barawa, Marka, and inland cities like Amud and Harar. Harar especially became a major hub later by the 16th century, carrying on these traditions.
Is there physical evidence?
Yeah, archaeology helps. At sites like Amud, they've found mosque ruins, inscriptions, things that point to active intellectual communities. And remember, these cities were nodes in a network, a trans-regional network. Somali scholars often traveled to study Mecca, Cairo, Damascus, major centers. Then they'd come back, bringing texts, bringing knowledge, and helping spread Islamic sciences, including arithmetic and astronomy locally.
Okay, and what about the big picture? The Islamic Golden Age, that incredible flowering of science and math across the Muslim world, how did that specifically touch Somali scholarly culture?
Oh, the impact of the Golden Age, let's say roughly 8th to 14th centuries, was absolutely profound everywhere, including Somalia. This was the time scholars were translating Greek, Indian, Persian texts and then building on them, developing algebra, geometry, advanced astronomy.
The foundations of so much modern science.
Exactly. Now, while we don't have, say, a major algebra textbook written by a Somali scholar from that exact period that survived the constant flow of people and ideas through pilgrimage, trade, study abroad guaranteed, Somali scholars were exposed to these huge developments. Imagine a Somali student at Al-Azhar in Cairo. They'd be encountering the works of giants like Al-Khwarizmi, the father of algebra, basically, or Al-Farghani, on astronomy, or Ibn Sina, who linked math and medicine. The curriculum in these big centers included both religious studies and these rational sciences. So, scholars, trained there, brought that integrated knowledge back home, and it filtered into everything from how cities were planned to how religious duties were performed.
Were there other global connections, maybe unexpected ones? I think the sources mention China.
Yes, that's an interesting point. The early 15th century visits by the Chinese admiral Zheng He, his massive fleet visited Mogadishu, other East African ports.
That must have been quite an event.
Absolutely, it definitely represents significant cultural contact. Did it lead to direct transfer of mathematical knowledge? Hard to say for sure, but it certainly could have introduced new tools, new ideas, or at minimum, broadened the horizons of local scholars and merchants. And remember, Mogadishu was already famous by then. Muslim geographers and historians wrote about its wealth, its organization, its lively scholarly scene. Zheng, he didn't arrive in some unknown backwater.
Right, it was already on the map. So this makes me wonder, how long did this rich intellectual tradition last? Can we see threads of it continuing much later, after the medieval period?
We absolutely can. There's great continuity. A really striking example is Hassan Aljabarti, an 18th century scholar in Cairo.
Centuries later.
Exactly. But his work, particularly with mathematics and astronomy, clearly shows the endurance of these Somali scholarly traditions. He actually taught astronomy at Al-Azhar, a direct link back to those earlier Somali scholars studying and teaching there. And his son, Abdal Rahman Aljabarti, became one of Egypt's most celebrated historians. He wrote the definitive account of Napoleon's invasion of Egypt. It really shows the multi-generational impact these East Africans, specifically Somali intellectual families, had within the wider Islamic world.
That's incredible. Are there echoes even today?
I'd say so, yes, in more traditional forms. Think about Somali poetry, which often has intricate structures or detailed clan genealogies which require systematic tracking, traditional calendrical calculations, even things like pastoralists using stars for seasonal guidance. That's ancestral astronomical knowledge, elders passing down oral knowledge about environmental cycles. It's a living connection in many ways back to these older systems of knowledge, including mathematical thinking.
So, wrapping this up, what's the big takeaway? It really means our picture of medieval Somalia has to be much richer, much deeper than just, ships and trade. It was a place where math wasn't just done. It was lived and integrated into the whole rhythm of society.
That's it, exactly. To sum up, the story here is one of really remarkable integration, transmission of knowledge, and clever adaptation. Maybe Somalia didn't produce the famous theoretical mathematicians known across the whole Islamic world, the household name, so to speak, but it cultivated this incredibly rich tradition of applied knowledge, knowledge that blended smoothly with religion, with commerce, with building impressive structures, with navigating vast oceans. Somali scholars were plugged into global Islamic learning. They received ideas, but they also transmitted them. They used the tools of mathematics not just to solve problems, but to understand their world, fulfill their faith, and master their environment.
It's a powerful reminder, isn't it, that the intellectual life in the Horn of Africa was complex, connected, and deserves way more recognition than it often gets.
Absolutely. And it makes you think, doesn't it, what? Other historical narratives, maybe ones we've overlooked, hold similar keys to understanding how knowledge travels globally, how abstract ideas genuinely shape daily life, and how we might find the evidence beyond just formal written texts. It's a real testament to how knowledge flourishes, not just in schools and libraries, but in everyday rhythms, in the stars,